Welcome back to Face It Net. Today, in this chapter, I'm going to talk to you about the TCP/IP networking and networking models. So this is your second chapter in the CCNA 200/301 series. So, what is the objective of these topics? We're going to talk about the perspective on networking, say the understanding of networking, and then we're going to talk about the TCP/IP networking models. Different types of networking models are available, and we're going to talk more about TCP/IP model. And then finally, we're going to talk about the data encapsulation terminologies. So we are not going to go deep into data encapsulation, but we're going to just talk about the terminologies we use in data encapsulation. Right, so let's go and have a look at the perspective on networking. So initially, the networking, when someone call about networking or when someone say networking, what comes to our mind is different to what comes to a network engineer's mind. So the network has two major branches. So as you can see in this picture, we got two different types of networks connected with different technologies. The one on the above with the Ethernet cable, you can see connect a PC and it's connected to a switch. The one below has got a tablet, has a wireless, and has got a medial intermediate device. We call it as a DSL device, and then it's connected to the enterprise. So technically what's here? So on the top part of the diagram shows a typical high-speed cable internet user. So the PC connects to a cable modem using the Ethernet cable. The cable modem then connects to the cable TV outlet in the wall using the round coaxial cable. Technically, you would have seen these types of cable from your antenna to your TV. So what happens is cable internet service provider service continuously so that you don't need to always go and connect it. The user can just sit down at the PC and start sending emails, or they can do browsing websites, or they can make telephone calls or voice over IP phone calls, and they can do everything because it's like a continuous communication. It's always active. The one below here, the lower part, it has using two different technologies. The tablet computer uses a wireless technology that goes by the name of wireless local area network. Remember, we have a LAN, local area network. Normally in LAN, we have different types of medium. So it could be a cable or it could be a wireless medium. So here it is a wireless medium, right? Or we call it as a Wi-Fi. So instead of using an Ethernet cable. In this example, the router uses a different technology. So here in this area, we use a different technology. This is normally we call it as a DSL. So this is where the internet technology started: ADSL, SDSL, XDSL. So those kind of different technologies. Of course, now we have moved from DSL to NBN technologies. But in this diagram, what we have got is a DSL to communicate with the internet. So both home-based networks and networks built for the companies make use of similar networking technologies. So they don't use any different types of network technologies. They use pretty similar networking technologies. Right. So if you come down here, TCP/IP model. So what is the TCP/IP model? Before we go into the TCP/IP networking model, we can see here there are three different types of images I have put together here. The first one, we can see it says 1980s and we have a name called IBM. The second one, we have same IBM and in between we have a TCP/IP, then the other windows. Then in 2000s, it's all about TCP/IP. So what these diagrams tells you, in the beginning, we had just one standard vendor specific networking model, which was the IBM's model. Then from IBM, we introduced IBM plus TCP IP model, which is where we have got multiple vendors started producing their own models. For us to intercommunicate different models, we need to come up with a common standard. That's where the TCP IP open standard proposed. And then in 2000, the vendor specific models technically disappeared and it's all become TCP IP model. So networking architecture or networking blueprint is what these ones are called. They define everything that should happen for a computer network to work, which is like how intermediate device communicate, how they have to convert the signals or the information to a signal, and what standards they have to use it, what is their operating system, what protocols they should use. These all defined under this networking blueprint, right? So today we are using TCP/IP, but vendors created the first networking protocol. These protocols supported only that specific vendor. In 1974, IBM published their first specific networking blueprint, which is called System Network Architecture. That was the first one, right? But the problem with this one, this has a limited connectivity. That means only the IBM devices can communicate. So we need to come up with different models because remember, year by year, different vendors started to produce different models. So we had to come up with a new one. So having an open vendor neutral networking model would aid the competition and reduce the complexity. When I say complexity, if you have two different vendors has got two different types of networking models, they can work within their networks. But if you need to communicate with two different vendors, it's always become a complex task for a network engineer to create that communication. So having an open common standard is the best to solve this complexity. So then what happens? The International Organization for Standardization, which is called ISO, took the task to create such an open standard model. So when they started creating the ISO model, at the same time, Department of Defense, which we call it as a DoD, the US Department of Defense, also started to prepare their own models, but technically that was prepared for their own purpose. They named it as TCP IP model. The standard open standard model was called as ISO, and then this one with the US Department is called TCP IP model. Since the open standard model was quite slow to implement everything and US standard one started producing a quite faster outcomes, more and more the corporates started to adopt the TCP IP model. So what happens is in around 2000, almost the ISO standard disappeared and everything became TCP IP model. So here today, in 21st century, TCP IP dominates everything. So TCP IP models originally creates almost entirely by a bunch of volunteers. It's a free